Welcome, everyone. Today, we are tackling a foundational pillar of enterprise AI, implementing network security and private networking configurations within your Foundry environments. In an era where data is your most valuable asset, securing the pathways to your AI models is not just an IT requirement, it is an absolute business imperative. Let's get started. Let's lay our foundation by understanding what network security means in the context of Foundry environments. When you provision an AI workspace or an Azure OpenAI resource, it traditionally comes with a public endpoint. However, in an enterprise setting, exposing your data to the public internet is a massive risk. We secure this by implementing virtual networks and private links. Why is this critical? Because securing your data in transit is mandated by compliance laws and protects against exfiltration. How do we do it? We physically disable public access on the AI resources and drop a private endpoint directly into your corporate subnet. For our deep dive, consider the assume breach mentality. If we strictly isolate the AI data plane using private networking and network security groups, a compromised front-end application cannot blindly siphon data from your models, because the network simply will not route that malicious traffic. Take a look at this high-level network topology. On the left, your corporate network connects securely to the Azure Virtual Network via ExpressRoute or a site-to-site VPN. Notice what is missing: the public internet. Inside the Azure VNet, we deploy private endpoints. These act as secure, internal gateways. Traffic intended for the Foundry workspace or Azure OpenAI routes exclusively through these private endpoints, ensuring that your queries and proprietary model responses never leave the Azure backbone. This is the gold standard for enterprise AI networking. As your organization scales, managing individual private endpoints for hundreds of applications becomes unmanageable. Enter the GenAI gateway. What is it? It is a centralized networking layer, typically Azure API management, that sits between your applications and your AI resources. The basics are simple. Instead of apps calling Azure OpenAI directly, they call the gateway. Why do we build this? Because without it, you face chaotic point-to-point connections, resulting in unpredictable latency and wasted resources. How do we implement it? We deploy APM into our VNet. This gateway authenticates the user, applies rate limits, and securely routes the request. Taking a deep dive, this architecture allows us to load balance traffic across multiple global AI endpoints. It maximizes our investment in provisioned throughput units, or PTUs, while keeping the network complexity completely hidden from the application developers. This diagram illustrates the conceptual architecture of a GenAI gateway. On the left, AI-enabled applications send their HTTPS requests. These requests hit the GenAI gateway, which is securely locked inside our VNet. The traffic first passes through a rate limiter to prevent abuse. Then, the router and load balancer take over. Depending on the network health and model availability, the gateway intelligently routes the traffic either to Azure OpenAI Endpoint 1 or to a custom LLM endpoint. This centralized control plane is vital for both network security and operational excellence. Not everything lives in the cloud. We must address hybrid networks. What does this mean? It's the secure integration of cloud AI with your on-premises data centers. The basics involve ensuring that inbound and outbound traffic between Azure and your internal network is impenetrable. Why do we need this? Because many heavily regulated enterprises have strict constraints. They must keep certain data in-house, but they desperately want to use Azure OpenAI. How do we solve this? We can deploy a self-hosted API management gateway directly within the on-premises network. Here is the deep dive. If you route all local traffic up to a cloud gateway just to apply policies, you introduce massive latency. By using a self-hosted gateway, you evaluate policies locally. Only the final, authenticated payload travels over the ExpressRoute tunnel to the Azure OpenAI models, dramatically optimizing performance while honoring strict network boundaries. Let's explore this hybrid deployment architecture. Inside the on-premises network box, our local AI application sends requests to the self-hosted gateway. Because this gateway sits physically in the local data center, it can instantly communicate with local monitoring and caching services. Once the network payload is validated, it traverses the secure ExpressRoute tunnel directly into the Azure cloud. There, it securely hits the Azure OpenAI PTU or TPM endpoints. This minimizes latency and keeps the enterprise network entirely closed to the public internet. Modern AI applications are complex. They are rarely just an app talking to a model. We must secure multi-service data flows. What is this? It involves enforcing private networking across an entire ecosystem of resources. The basics: a typical retrieval-augmented generation, or RAG, application interacts with a web app, a search database, and an LLM. Why is this challenging? Because a chain is only as strong as its weakest link. If your OpenAI model is private, but your AI search index is exposed to the public internet, your data is compromised. How do we secure the whole chain? We use VNet integration for the app service and private endpoints for both AI search and OpenAI. For a deep dive, consider the actual data flow. The user talks to the web app. The app queries AI search for context and sends that context to OpenAI for summarization. By networking these together internally, these hops happen entirely on the Azure backbone, invisible to the outside world. This sequence diagram maps the highly secure data flow of a RAG application. The user sends a prompt via HTTPS to the web app. Because the web app has VNet integration, its next step querying Azure AI search happens over an internal IP address. Search returns the secure context data. The web app then bundles the original prompt with this context and sends it to Azure OpenAI, again over an internal IP. Finally, OpenAI returns the summarized response. At no point during the internal processing does the sensitive enterprise data touch a public network. Network security is incomplete without identity. We must establish identity-driven network boundaries. What does this mean? It means combining our private VNets with Microsoft Entra ID to achieve true zero-trust architecture. The basics: network isolation keeps the outside world out, but Entra ID ensures internal components only access what they absolutely need. Why? Because if an attacker somehow breaches a virtual machine inside your VNet, we cannot allow them free rein over the AI models. Network access must require explicit identity verification. How? We assign managed identities to our web apps and gateways and use Azure Role-Based Access Control, RBC, to grant permissions. The deep dive here is critical. Stop using API keys. By assigning the Cognitive Services OpenAI user role directly to your gateway's managed identity, traffic is authenticated dynamically at the network layer. You eliminate key rotation and eliminate the risk of leaked credentials entirely. Look at how identity acts as the ultimate firewall here. The web app or bot service attempts to connect to the backend databases. It doesn't present an API key. It presents its system-managed identity to Microsoft Entra ID. Entra ID verifies the identity and issues a secure token. Notice the dotted lines. The web app is explicitly granted the Search Index Data Reader role for AI search and the Cognitive Services OpenAI user role for OpenAI. Without this cryptographic token, the private endpoint simply rejects the traffic. Identity and networking work hand in hand. A secure network must also be a resilient network. That brings us to network-level rate limiting. What is this? It's the enforcement of strict throughput controls at your gateway to protect your backend AI models. The basics involve setting limits on requests per minute or tokens per minute. Why is this a security issue? Because uncontrolled traffic can lead to denial of service outages. Furthermore, AI resources are expensive. Unchecked queries will rapidly burn through your provisioned throughput units, or PTUs. How do we control this? We configure policies in API management to throttle traffic based on the user's identity or origin IP. Diving deeper, we can implement intelligent traffic shaping. For example, if network telemetry detects that PTU consumption has reached 90%, the gateway can automatically drop low-priority, background batch jobs, preserving bandwidth exclusively for high-priority, real-time user chats. This flowchart demonstrates intelligent network-level rate limiting. We have two traffic streams hitting the gateway: traffic shaper, mission-critical chat, and a background batch job. The gateway continuously monitors backend capacity. If current PTU consumption is under 90%, it processes both requests safely. However, if the network is congested and PTU exceeds 90%, the logic shifts. The gateway processes the chat only and explicitly drops the batch job, returning an HTTP 429 too many requests error. This prevents network saturation and ensures critical systems remain online. We have built the fortress, but now we must test its walls through security evaluations and threat modeling. What is this? It is the systematic testing of your network endpoints against adversarial payloads. The basics dictate that before any AI application goes live, it must pass rigorous, simulated attacks. Why? Because firewalls only block bad packets. They do not understand bad text. Malicious actors disguise destructive commands inside normal data, attempting to inject prompts that override your system rules. How do we secure against this? We use the Azure AI Evaluation SDK inside our CI/CD pipelines to relentlessly attack our own endpoints. For a deep dive, our pipeline scripts literally simulate hundreds of indirect prompt injections using SOL datasets. If our gateway or model fails to block these malicious payloads and leaks data, the pipeline fails automatically. We never deploy untested boundaries. Let's trace an automated threat modeling sequence. The CI/CD pipeline initiates the test by loading an adversarial dataset filled with malicious prompts. It commands the Azure AI Evaluation SDK to inject this malicious payload directly into our gateway and model infrastructure. Our security architecture does its job. The content filter detects the attack and blocks the payload. The system reports back that the evaluation passed with a perfect score. Only upon receiving this mathematical proof of security does the pipeline approve the actual deployment to our production network. Let's tie all of this together with a real-world use case. Imagine a global financial institution, a Tier 1 bank, that wants to deploy a generative AI assistant to analyze sensitive customer portfolios. The basics are strict. Absolutely no financial data can traverse public IP space. The why is simple. Violating data sovereignty and compliance laws would result in massive fines and loss of trust. So, how do they execute this? The bank architects a comprehensive GenAI gateway inside a heavily restricted Azure VNet. They utilize private endpoints for every single component from the web frontend to AI search and Azure OpenAI. Let's look at the deep dive. The analyst requests data from an on-premises terminal. The traffic flows over ExpressRoute. The APM gateway authenticates via Enter ID, actively strips out PI, and securely routes the query. 0 bytes touch the public internet. They achieve cutting-edge AI innovation while maintaining impenetrable regulatory compliance. Our final diagram illustrates the bank's impenetrable architecture. The bank analyst initiates a query from on-premises, traversing the secure ExpressRoute into the Azure VNet, hitting the GenAI gateway. The gateway enforces Enter ID authentication and routes the traffic through a local data masking service to remove PI. Finally, the sanitized request travels over a private link to the isolated Azure OpenAI endpoint, which accesses customer data strictly through another private boundary. This is how you implement flawless network security and private networking for enterprise AI.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment. Or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.